There we go. Welcome all to the last half day of our DAMA Days Canada. And to kick us off for the afternoon, I've got Mr. Bruce McCartney here. And Bruce, I lost your bio. Oh, no. I've known Bruce for a number of years.
Yes.
In the data space. He's an expert in a number of things. An expert in database design, performance tuning, replication, high availability, and security. He's an excellent problem solver and enjoys sharing his knowledge with clients. Oh, nice kid. His professional background is extensive, including 30+ years of involvement with Oracle. Bruce is Oracle 12G certified professional, as well as certified data vault modeler, something you've been doing quite a bit lately. I
Yes.
understand. You're teaching in that space. He's the co-founder of DB Corp, or any Calgarians who probably do remember that, of a certain vintage anyways. Information system and for 4 database partners. Bruce was instrumental in the organization growth, designing many business and service methodologies in use today. I will leave it at that, Bruce.
Thank you very much, Ron.
Want to fill in some of yourself?
Yes, yeah.
Take it
Thanks
away.
very much. Welcome, everybody. Thank you very much, Ron, for that. And thanks for inviting me today. And thanks to the DAMA board for organizing this meeting. I think this is something that hopefully we'll see more of in Calgary. We need more of this knowledge sharing and whatnot. As Ron mentioned, I've been working with data for quite some time here. I'm just going to go through a couple of the slides here. Thanks for the rest of the people who are probably seeing this presentation. Most likely are going to be watching a recording of it, I'm guessing, because I know Bill Inman is presenting up in Edmonton at the same time here. So if you're watching the recording of this, I think that's good because you can pause it. I've got lots of information here, lots of web links so you can go look up, so you can pause the recording. The guys here live, all you can do is hopefully laugh at the jokes. And if you're watching the recording, don't worry, you haven't hurt my feelings at all. It's okay, Bill. But the rest of you guys, hopefully you'll find this somewhat interesting and a little bit entertaining at the same time. So I'm going to be talking about leveraging data, and I put the money floating up there to try and get your interest in this topic. And I'm really not going to be talking much about data. I've worked with data most of my career, but I've found what I've been working on lately is business intelligence and trying to get data to make better decisions. And people haven't done a good enough job of that. It used to just drive me crazy. So this is what I'm going to be talking about today, is how to get all this data and make use of it, make it useful. So my objectives for the presentation, and I'm going to have to do this. I was afraid I was going to have to do this, but I can't see this laptop. Is to maximize the utility of your data by understanding and extending its meaning and tying that to goals and outcomes. Not revolutionary stuff, but now we're getting to the point, I think, that we can actually mechanicalize this and computerize it so that we can do it quite quickly. In order to do that, we have to be able to represent knowledge. And how do we represent knowledge as opposed to representing just data? So we'll talk a little bit about that. I'm going to go through a model that we use for business intelligence that helps us understand where knowledge fits in the puzzle. And really it's ontologies and formal ontologies that will allow us to do this. So we're going to talk about machine readable models that can actually also understand the meaning of the data, which is the final frontier in my opinion on this stuff. And then I'll wind up the last part of the presentation talking about a sort of a new discipline called decision intelligence, which ties this knowledge together to help us make better decisions, wise decisions associated with that. So this is my information graphic. It's fairly accurate. I've worked in Calgary most of my life here, and one of the companies I've worked for. The only thing that's not quite accurate is the girth of the guy sitting at the terminal. I think I've got a little more middle section than he does. But from this, you can get a little bit of background on me, but you don't get a lot of knowledge about me. So what I'm going to I'll give you a sneak peek here about how you can represent knowledge. And this is a sample knowledge graph about me. And I'm going to see if I can make this thing work. There's my pointer. That's me in the middle of that. And a knowledge graph is really basically an expandable definition of objects and relationships between the objects. And there's different ways in which you can represent those things. So this is me, and it says that that I'm a person. Here's my name. There's a couple of things about me that if you're interested, personality types. people can know me very easily now because I'm a personality type Enneagram, if anybody's seen that before. If you haven't seen that before and you want to know what an Enneagram 5 is and you go look it up, you're an Enneagram 5 because you're an investigator is the title or the name of that type of person. Anyway, so let's move on to the presentation roadmap. I'm going to start by trying to introduce what I think the problem is, the problem that we've had, because I think the problem is showing up in that we're not making good decisions based on data. So that the reason for that, we're going to talk about that for a little bit. And then I'm going to give you a model for business intelligence that I didn't invent, and none of this stuff really I've invented. I've just sort of curated it into this presentation, the DIKW model. And I'm going to go through some of the definitions of the layers of that model so that we can begin to talk about formal ontologies to begin to use those things. And really the last half of the presentation talks a little bit about knowledge graphs and representing knowledge as data, again, but a different format of data that can be used by computers and people to understand the meaning of what we're talking about. And then finally, I'll introduce decision intelligence into the whole mix so that we can tie what we really want to have happen to the data that we're making decisions about. And this works very well for business intelligence purposes, but it also works for personal things as well. It's really how do we make decisions? What do we do about them? So let's begin by understanding what the problem is. And I think the problem really is we're trying to model ambiguity. Ambiguity means that there could be many meanings to something. We want to be clear about it. And if you just have a database schema, you don't really have a clear definition of what things are. So I'm going to play a sound here. You're probably not going to hear it, so I'll just say the word. But what is the meaning of bear? And bear, has multiple meanings. If you really look it up, there's 3 nouns and 17 different verbs that are done by the sound bear. And it's very difficult. So how do we get meaning from things? We use computational linguistics and natural language processing. Now is to the point where you can actually understand things. So if you have interviews with your users, one of the things that we've started doing is just record those and turn those into text, and you can feed them into things that can understand what those people are saying and turn that into a model. And I'll show you an example of that coming up later on. But if you just say the word bear, you don't know. Bear with me as we go through this. This is going to take a little while. You want to classify things, okay? Everything, it turns out everything is an instance of something else, right? And that's how people learn, and that's how people express knowledge. We're not talking about data in this presentation, more about the meaning and thinking about that data, metadata, if you will. So if it was just about this, then here's the stable data model that you could have. And this model will actually be the only data model that you need, and you can go off and you're done. But things are related to other things isn't that useful. There was a presentation a year. Tim Gorman is an Oracle guy. I don't know if Simon's around, remembers him. He had a chapter in a book from an Oracle Oak Table, it was called, about an Oracle consultant who implemented a system in one table with recursive relationships. It was cool for him. It was unusable for the customer. It's just not that useful. So we need to understand the meaning of our data in a way that we're searching for it. We're not searching for the meaning of life. We're searching for the meaning of our data. So if I'm given a data set, something like this, bear 42, already we have a little bit more meaning in that because we recognize that as a tabular row of information. Somehow 42 is tied to the bear, but we still don't know what that means. So one of the things that we're going to try to do with ontologies and taxonomies is trying to fit the meaning of these things into something that we can use. And the way that we do that primarily now is an ontology model. An ontology, I'll give you a definition of all of these things as we go through this, but it really stems from the natural way that people express things as hierarchical. Things are types of other things. And a taxonomy is simply a hierarchy. And we have lots of taxonomies built into us that we understand how things work together. And bear, it fits into one of them. It plugs right into the animal kingdom, right? And if we know it's the animal bear, we know an awful lot about it. So we understand the meaning of what that is. The other thing that we have to do in an ontology is we have to be disambiguators. We can't have something that's gray. We need to be precise about when we design and define things. We call that a controlled vocabulary, right? A glossary, a thesaurus, these things. People get unhappy when you suggest they do these things because it sounds like it's going to take a lot of time. but it's so important so that you're always talking about the same thing when you say customer or policy or part or any of those things that you're trying to gather data about. You want to take that information and maybe plug it into your definitions and your taxonomies. So here's a bit of a sentence with the word bear in it. Does a bear poop in the woods? That gives me a lot more information, right? I know what kind of bear this is now because I have this animal kingdom. I have this understanding. I've got a taxonomy here that says that it must be one of these bears. It's probably one of these brown or black bears because polar bears don't live in the woods. And that's an inference, right? That's taking the context of what's going on and getting more information from the sentence that we've got there. This continues on. And what's interesting about this, I think, is moving up the hierarchy causes a loss of information. You start at thing, and as you go down, you get more information about that thing. But as you go up the hierarchy, you get less information. And that is really the measure of that from a scientific perspective is called entropy. And we'll talk about that here in a minute too. So you can now add multiple taxonomies together. We know the animal kingdom, but we also know habitats and locations and things like that. So where it eats, what kind of bear it is, you get more and more of a conceptual model of what that bear is. It's a shared conceptualization, and that's really what an ontology is by definition. And it's something that helps us define the meaning of what we're talking about and what we're running our business about. So let's disambiguate. First of all, the context of this presentation really is about business intelligence. So I'm going to maybe give you a definition of business intelligence. And I'll start out with, for a lot of people, business intelligence, the term came out first in 1958, way before, a lot of computerization that happened to things, right? It's just really, if you read what the definition is, it's looking at things and deciding the right things based on a goal. Right, taking your goal and looking at the data and all the alternatives you have and making the right decision or the best decision at the time. So I'm going to define the term business intelligence for the purposes of this presentation is the effective use of data and information to make sound business decisions. So, and one of the things I'll do in the presentation, and maybe you can see towards the bottom here, is I put some links in here. So again, if you're watching this on a recording, you could pause and go and have a look this up. And I didn't make all this stuff up. It's on the internet. It's got to be true, right? That's my fact checking algorithm. But I really love this book by Ronald Ross. I read earlier this year, Business Knowledge Messaging, and he says never invent a definition if you can adopt one. And I thought I was just being lazy, but if somebody else has done the work for us, why don't we leverage what that work is? And in terms of ontologies and things like that, that really helps us link together sets of disparate information or data associated with it. So the model I'm going to present about business intelligence is called a DIKW model, and it's certainly not new. And the reason I think I like it is I consider myself a data person. I've worked with data my entire career, and this model is based on data. Data is the foundation, and data to me is real. The rest of it is not real. It's all in our minds. It's meta. It's fluffy. And I used to actively avoid that kind of stuff. But I found I had to get in there because we're messing this data stuff up. All we're doing is producing a bunch more data and not really getting the value that is promised by business intelligence. So from a business intelligence perspective, we have this source data set, and the end goal to this is just give me any data set and we'll figure it out, right? That's the idea here, but we're a long way from that. What most companies do right now is they'll put a little bit of context together with that data, producing a bit of information, and then they'll store it again as more data, right? So if you create a star schema, that's information, accessible data. Right, but we've created some KPIs, we've done some metrics, we've organized it, contextualized it, we've made it a little more useful, and here's some more data. When we take that information and start understanding it and learning from it, that's when we develop insight and make knowledge. So knowledge is this synthesized learning. It's really the answers to the questions that we have. Information, as you'll see here in a minute, really arises because we have questions. And if there's no questions, there's no information. And the final step to this puzzle, which is where we want to be, is decision-making process. What are we going to do? We have to use foresight. We have to use foreknowledge of the situation that we have in, and make the best decision. And we like to use data in order to do that. In order to do that, we sort of have to go through this entire stack of concepts. So I'm going to go through each one of these quickly, maybe review for some of you folks, but it's a little bit different way of looking at things. And again, Ronald Ross, I love the definition that he has for it. It says data are messages to people of the future. And there's a lot of meaning packed into that. And I like the word future means that data must persist, right? It actually exists and somebody else can look at it later on. That's what data is. And it's a message. So there's an intention associated with it. But data, this is has been around a long time. And this is an example of the first known data that I could find. It's a rock that somebody drew a picture on. That is actually data. That was a message that somebody was trying to give. We don't know what it is. It's not very informative, because there's not much metadata around. We don't know a lot about it, but it is sort of the first instance that I've found about data. So data exists, it's real, that's the way I think about it. Data is a set of values of quantitative or qualitative variables about one or more things. Datum is the single of that. So most of the time when we talk about data, it's a set of datum that we're dealing with, right? I like to think of it as it exists and it has a location at a point in time. And this is the stuff we have to secure. It's the stuff that it costs to store and all of that. And it's very important. But what we do with that and how we use it requires us to have more information about that data. So here's my data set, Bear 42. Let's see if we can get a little bit more creative on what that actually means. Does anybody know what that means? I don't think you do. You can't. It has a schema. Even that Bear 42, there's a lot of stuff in there. First of all, I've got the symbols BEAR in that order is a whole bunch of information. And then associated with it, because it's in the same table, 42, we have a numbering system. So we know that this is some sort of metric. And data can be enhanced by more metadata. So this presentation really talks about more of the meta stuff. The data stuff, I'll leave that behind now. We'll talk about metadata. So if I put a little bit of metadata on this, and the minimum amount of metadata that we usually get is a schema that has the table name and column names, hopefully. Some cases not. But if you have that, now you know a little bit more, right? You know this is New York Zoo animals, and 42 is the height in inches. Does that mean anything to anybody? Probably not, but it's something that we can begin to get more information from. So data exists, it's real. The rest of this stuff is not real. So information defined, if you go up the ladder one more, information really doesn't exist. It's not matter and it's not energy. It's a concept, right? And information is, we're going to define it as processed, organized, and structured data. And it provides context and it resolves uncertainty. Information answers a bunch of questions, basically. And when we started to digitize things, the questions that we were asking are yes/no questions. And binary results, computers are very good at that. What's happening now is with quantum computing, we have more than 2 states that we can very rapidly process. We got more, the quantum computing is going to blow this stuff right out of the water, but digital information is the basis of most of our work right now. So information really doesn't exist without questions. You can have data. That rock exists. But if you're trying to figure out what it's trying to say, is it somebody back 73,000 years was saying, this way to my house, or stay away, there's a tiger around the corner? We don't know, because we don't have the information. So we have questions about it. When we answer those questions, that's what we're doing with information. Unfortunately, when we generally create more data as a result of asking questions. We'll change the form of that data into a new set of data. Information is part of a cycle. Questions lead to information, which leads to more data, which leads to more questions. It's a continuous loop here, and we're not going to ever run out of data here. Information binds together data with context. And there's a whole branch of science called information theory that talks about it as a measure of entropy. And entropy is really sort of the amount of disorder or randomness. The more information you have, the less you don't know about something, I guess is one way to put it. And I've got a link in the bottom of this slide here to a presentation by a colleague of mine out of Australia that talks about, if we want to transfer information between things, we have a sender and a receiver, and there's distinct properties necessary to go through and make that successful information transformation. And that's why sometimes you can get people looking at the same thing and having a different conclusion from that, right? And it's because of the communications don't break. And I know that's a little bit hard to read, but hopefully you can click on the link and watch the presentation. So the second last piece is knowledge. Knowledge is even a little bit different than information. Knowledge really is a combination of information that you've received tied with your values and your beliefs. It's really the things that you understand. You stopped asking questions about it because you know, right? We know the animal kingdom. We're not doubting those things. We know those. It's the reusable answers that we have. It's the truth, if you will. I was going to heckle Simon on his source. The single source of truth really is a saying I really don't like, because everybody has a different truth. And the truth is manufactured inside you. It's not, and what we're going to try and do with some of this knowledge work is try to, from your company's perspective, is store that and represent that in a way that people can look at it and a way that computers can look at it. And then we can start talking about the same thing. So knowledge reflects our meaning and our understanding of the data, and it's ours. Right? It's not, it's individual, and you know, different individuals can look at exactly the same situation and have a completely different truth about that. Last layer in this model is wisdom, and wisdom is really defined as, and here's another quote that I got. I love these memes on the internet, and I don't know if Jimi Hendrix wrote that. I was thinking, well, how would I fact check that? And I fact check it with the way I fact check most things. You know, if it's on the internet, that didn't George Washington say that? It must be true. No. Wisdom is the ability to contemplate and act using knowledge. Okay, so it builds upon these things. A better definition that I use is it's the capacity to have the foreknowledge, right? You need to have some knowledge of something to know the consequences of all the available actions. So it's action oriented. What am I going to do next to yield or take the options that have the most advantage? And I didn't make this up. It's off of Wikipedia, but it's a pretty good definition, I think, as what this is. And so one of the key points of this presentation that I have is be more like Einstein with your data. And I want you to read this mime, because this is a really important one. And I've even created a little graphic about it. And you can tell I'm not a graphic artist, but that's my idea. And what Einstein is saying is, I spend most of my time finding what the right questions are to ask. And that's where I think what we're doing wrong in our business intelligence world is we're actually doing it the other way around. We assume in IT that we know the question. We don't even, oftentimes we're not even talking to the people who have to make the decision. We're just saying, oh, it must be in this data. It's got to be, you got this big database. It's got to be in that. We'll put it all into our business intelligence framework and off we go. And that takes a lot of time. And I think, you know, as Einstein sort of, you know, saying in that quote is, if you spend a little bit more time finding out what it is you're trying to do, what are the goals, the desired outcomes that you have, then you can tie what data supports that. And that's what decision intelligence is trying to do. And I'm going to probably have to skip over. I've got a little, one of the, you know, it's asking the right question. And this is one of the epic wrong question clips, I guess. And I don't know if you guys can see it. I don't know if you'll hear it though. Oh. This is Peter Sellers, and I apologize, you won't be able to hear it, but it's, does your dog bite? The guy says, no. And then he reached down, and of course the dog bites. I thought you said your dog doesn't bite. It's not my dog. That's the wrong question, right? Not my dog. So wisdom is knowing what questions you want to ask your data. And I really wish I could have had that shown of it. So let's summarize this model. There's various ways in which, in all layers of this, we have to sort of persist more data about that. So there's some common models to go through. From data warehousing perspective, we've got third normal form dimensional. I'm a data vault fan. I'm pretty confident I could, you know, have a good discussion as to why that's the best way. I've tried to bold the best ones that I think are here. Star schema is really good for ad hoc queries. The people think about that, dimensional analysis, facets and things like that, but there's others. And then as we get into the higher levels of that model, knowledge representation is a little bit more difficult. We have these knowledge bases. We've tried a few times in the past, frequently answered questions, right? That's what knowledge is. A lot of people say that's frequently asked questions. No, I don't want the question. I want the answer, right? Frequently answered questions. And really it turns out the internet has all human knowledge is available on the internet. It's incredible. So this thing, partially, you know, the way that we're trying to do this, you know, in a public way is, you know, with the semantic web, there's commercial companies that are doing it, you know, in a nefarious ways and things like that. But the semantic web is really a knowledge graph, and it's based on an ontology representation called OWL and a data model called RDF. And I'm going to go through those here in a minute. And then representing wisdom is used. Causal graphs can help us represent a decision intelligence associated with that. So let's start with the desired outcome and work our way back to what data can be brought to bear to get us to that outcome with the most likelihood. So let's talk about these knowledge graph things. The semantic web, another term you'll see, is linked to data. It can grow infinitely, right? It's computerized knowledge. And a graph data model is simply a triple store. So this is a little uncomfortable for me because all of the data modeling I've done now comes down to three things: subject, predicate, object. And these triple stores that they have, and they're, you know, Siri is using this, all kinds of organizations have used this, can get large, but there's just three things in it. So Oracle has a triple store. If you look at a graph database, it's really just a triple store that's associated with it. It's really quite interesting. RDF is the way to express that. And there's just a bunch of these things, lots of them. So Paul McCartney is part of the Beatles. Here's a little more, you know, detailed on that, where there's other members of the Beatles and they're also solo artists and they've done albums, and this is how a knowledge graph works. The nodes are either things or data, and the edges, which are the lines between them, are properties, you know, of the node, which is either an object or a piece of data. They all have properties, and it fits together. So one of the things we have to do is sort of manage identity in these RDFs. And the way we do that is called an IRI. And you've seen these things. That's how the internet finds stuff, right? HTTP : or mail to : that's an IRI. It's an internationalized resource identifier is what it's used for. But every node and every edge has an IRI associated with it. So then you can build all this stuff together. And the nice part about it is you can serialize it and read it by a computer. So these triples can be shortened and syntaxed so that it takes a little while to be able to read this, you know, and comprehend it as quickly as you can a graph, but they're workable. You can understand it, but certainly computers can understand it. And it's a formalized specification that you can now also search. So how are we going to search this stuff? There's a language for it called Sparkle. Sparkle is also a triple. It's subject, predicate, object with wildcards. And the triple pattern is sent to, and the thing that's interesting about Sparkle, I find, I'll show you that on the next one. Is there anything here I want to talk about? No. The syntax reminds me a lot of SQL. It's a structured query language. The only thing that's missing from here, can anybody pick that out? From. Just select from all the knowledge we have. I don't have to join things. I don't have to tell it where to look. I don't have to do anything like that. I just say, I want to know, right? Because it's all been laid out in a fashion that the location is built into the database, which is really, I think, pretty cool. So now we can begin to search our knowledge. And this is one of the providers of this data.world is a knowledge-based metadata company, but they do a lot more than that. But they've got a product now that lets you search your knowledge, just not your data artifacts. Right? We have so many data artifacts out there, and you know, big data may have been a bit of a problem for that. We're gathering all this data. Let's try to search our knowledge. And the way that we do that in the semantic web, there's an architecture for it called the layer cake. And right in the dead heart of that layer cake, circled by the red, I'll try and point you to that, is the word ontology. What's an ontology? An ontology is a branch of philosophy that studies concepts like existence, being, and becoming, and reality, and meaning. And that kind of stuff I used to just think is silly. But it turns out in computer science, if we start using it in a formalized way, it's pretty darn useful. So let's go one step further. and defining our ontology, we want to have a so that. I really think we want to know why we're doing this. So the term ontology, this is from Tom Gruber back in 1992. Tom Gruber is the guy who invented Siri. Reset my phone. Anybody? No, it's better than that. That's a bit of a joke. Ontology is a formal machine readable specification. And it is an explicit specification that includes things like concepts, properties, relations, functions, constraints, and axioms. These things can be used so that we can automate reasoning and inference. So we can do things like, we know that bear must have been a black bear or a brown bear because it was in the woods, right? Because we have this knowledge about the bear and the woods. So we can now do this with computers as well. It also enables us to share and reuse this. And we saw a quick knowledge graph with just Paul McCartney in it, no relation, by the way, unfortunately. And we plug him into that second one, and now we can merge knowledge graphs together. Ancestry.com. The reason I know he's no relationship, because I got, for Christmas present, I got Ancestry.com and sort of, I got a little obsessive by there, and I went back and I tried to find a relationship between me and Paul McCartney, and it just doesn't exist. I went back to the 1400s and I just couldn't find it. But what was nice about that is a distant cousin of mine, Chuck, and I know Chuck very well. Chuck is a pretty organized guy, and he had done a lot of his side of the family. So when I said that Chuck guy is my cousin, boom, all of his relationships were brought into my knowledge graph. All of a sudden, I had more than tripled the amount of knowledge I had because I could share and merge these things together. And we can do that with all kinds of things in the knowledge graph. It just structurally works, which is kind of fun. And the reason I'm really hopeful about this is because it's publicly funded and publicly run. W3 is a worldwide consortium, I think, maybe. They have developed some standards that nobody owns, which is really, I think, very encouraging. And what they've defined is the ontology web language. So it's web focused for sure. And as I used to say, this internet's, it's just a fad. It's not going to be here for a long, it's here to stay. And so let's reuse some of the things that they've done in our businesses now. They've been doing it for quite a while, but they've been kind of off in the labs doing this kind of stuff. And I go back to Ronald Ross's thing. I never want to, I don't want to invent a definition of stuff. If somebody's already done it for me, I'm very happy to use that. So this is a way we can use that. We can take my cousin's ancestry and I'll just use it. And then I have that for free. So examples of using ontology, well, friend of a friend is the one that you've seen a lot, ancestry-like, linking of graphs, people, remember the Panama Papers, the scandal that happened about that? They used a knowledge graph and the friend of a friend way to track and go through all of the different companies and stuff like that they were trying to hide these documents from. It was really quite an interesting thing. WordNet is really cool. And bear, here's a screenshot of WordNet. I think there's 2 different nouns and 13 different verbs for it. We know when you say bear, you can access this and get a real good definition of what bear is. Now imagine if you could do that for your company's customer or your policy or your whatever it is that you guys are looking at. There's a few public ones out there. SCOS is one that's a knowledge organization system, lots of metadata, lots of data formats, lots of things like that are available. DBpedia takes Wikipedia, all of the stuff in Wikipedia, sucks it into a knowledge graph and has all the classes and stuff like that for that. KBpedia is a knowledge base as well, based on a different upper ontology. So the upper ontology is where you start with. That's your beginning of where you're going to look. I call it thing 1, right? That's where you start. And there's several of them. The one I've used a fair bit, basic formal ontology, because it has this thing called an information artifact ontology, which is included in that is data sets and databases and things like that we're dealing with. So the basic formal ontology it came from biological sciences because they wanted to keep track of all of the different biology things that we're doing. There's a few others here that I really haven't gotten into too much. Some of them are commercialized, some of them not. I'll show you what this looks like. Here's BFOs, and it's 2.0, but it starts at its top level thing is called an entity, and then everything is either a continuant or an occurrent. So it's something that exists or something that happens. And then Data Vault, if anybody's used Data Vault, that's hub and link. I mean, it's just a natural way to classify things. And then if you use this, you get all the properties associated with the ontology and the meaning associated with that. There's a KBpedia utility out there that has some use cases here. The reason I like this graphic is because they tell you about what you can do with it. You can do concept tagging, entity tagging, mapping, all kinds of things can be used for this, as well as machine learning and semantic search, right? So those are the things that I was talking about earlier. Machine learning, useful machine learning, it can help take your knowledge and help you make better predictions and make better decisions based on that. So the use case for that, I've got this cheesy graphic here. I don't have any sound on this one, but here's your ontology walking around in space. This is an actual video of a brain dendrite, I think axion, linking up with another one, right? Shared conceptualization, and they're just wandering along. But if you guys can tie those things together, if we tie them together, then they, stopped. Yeah, there we go. Now I am lost. I apologize for that. I'm going the wrong way. Keep going back. There we go. Yeah, that's the one. Anyway, let's move on. Some implementations for ontology. You can use a virtualized ontology on top of your relational systems. The w3org.org has an R2 to RDF, so relational to RDF specification. This on top tool is a bunch of Java that sits on top of that, so you don't even have to create a knowledge graph. You can use your relational systems in that way. I haven't used it. It exists, and it's existed for a while, so I assume it works. It's on the internet, right? It's got to work. There's some commercial knowledge graphs out there that I have used that got a bit. Stardog, I think the thought leader on this really is Cambridge Semantics and Anzo. Their platform is all of the things that big data platforms have, multiple nodes and all that stuff, and all the different database things we need in a triple store. But now we're storing things, it's so simply, it just kind of contrary to what I've done for most of my career. There's Top Quadrant and Eureka from Data World. One is a company that has curated ontologies. So if you don't want to go and build your own ontology, you can go and buy one from them, right? And we've had models before. We've had public petroleum data model, and airline industry and insurance industry all have data models, but I don't know that that's been all that successful. And I'm really interested to see if the knowledge model can be used and exploited that in that fashion. And a lot of this stuff is open source, which is, again, very, very appealing to me, being from Scotland, I guess, maybe. I don't know. Okay, so how can you create your ontology? There's startups now, one called Limba, who will automate the development of your ontology because of the way that we can parse language now. We can take, and we've done this in a couple of sites. We haven't used this tool, but if you record the interviews you're having with the people who know what they're talking about, you record them and you feed them into something like this product here is called K-Extractor, that creates your ontology from the words that have been said about your company. All the documents get fed in there, and then out from that you have all of your knowledge. You can search your knowledge and do this in an automated fashion, which means that I can retire, once we've done all that stuff. So the use case is really using natural language processing, which has really exploded of late. They're so much better than they used to be. And I was going to demonstrate that. This might not work, but I'll demonstrate that now. This comes with the, now are you seeing my words come across there yet? No, uh-oh. It says it's listening. Oh dear. Okay, it has to go back to the internet, and generally Windows has a core piece that PowerPoint plugs into that in real time doesn't work. That's like most demos. I shouldn't have done that.
You've all seen it on Teams meetings.
Sure. Yeah.
And it's getting better and better.
Oh, yeah. It used to be comical, right? You used to laugh about that. No, I don't want to do that. No. And now when I ask Google, I don't want to say Google Assistant too loud because it might think I'm talking to it. But when I ask it a question, it comes back with a darn good answer, or at least a website that gets me going with it. So, so you can now begin to use this to develop your ontology, create your knowledge graph. And I'm going to say, so what? You've got all the knowledge now, you're going to search it, what are you going to do with it? We still haven't got that utility, the usefulness, the leveraging going on here. This is where decision intelligence comes in, because that's where we can apply wisdom, right? Remember, wisdom is finding the right question to ask. This is how we can do that. We can get the right questions and then get the answers from the knowledge that we've developed from the information that's been provided through our data. Simple. Decision intelligence is a fairly new idea. I pulled this off of W3 back in 2012. There's an ontology for decision making, and a whole set of people out there now that are working in decision intelligence. And one of the things that I found that, you know, and unfortunately I do this a lot, so I'm one of the people that has perpetuated this problem. But we tend to try, as IT people, to try and answer all possible questions. I need to have all possible data. Well, we're running into trouble doing that, because the amount of data that we're having and being created, especially by IoT things and stuff like that, is exponentially growing. We're not able to process that. So if we can take and really find out what outcome is desired, that's what we start with. What are we trying to achieve here? And then work backwards through the data and ask better questions about it. That helps us ask those better questions. So instead of loading up all of the data, I can now focus on the data that is relevant to the desired outcome that I've got. And that's essentially what decision intelligence is trying to do. And I got a couple of links in there. And there's an extreme programming example. What this does is it separates the signal from the noise. We've got so much noise coming in us, so much data, that we need to be able a way to focus our attention. This is the way to do that. And the rest of that stuff is YAGNI. It's an extreme programming term. You ain't gonna need it, is what it stands for. And it turns out, you know, roughly, depending on who you talk to, it's 10% to 5% of the data accounts for most of the decisions, right? We're loading way too much data, and I consider myself one of the guilty parties in this. So the traditional view of this, and this is a book by Lauren Pratt, who's one of the thought leaders in this decision intelligence space, is the traditional view is I've got all this data. What decisions can I make with this data, and what will the outcome be, right? And what we want to do with this decision intelligence view is wisely turn that around. What is it I'm trying to, what's the outcome that I want to have happen? And then what decisions will get us there? And finally, what data, analytics reports, human expertise, and other assets are relevant. It's not always just data. Some things are not known, right? So we might have to actually get somebody's opinion, an expert, to make some judgment associated with that. So decision intelligence is something that you're seeing a fair bit in the news now. I don't know if anybody's heard it or seen it or anything, but Gartner talks about it in the last couple of years. So it's something that's on their radar. And Cassie Kozakov from Google, who's got some awesome content online. Her job is chief decision scientist. So they talk about using data to drive decisions, make better decisions from your data associated with that. So what Lauren does is she develops these, you know, directed acyclic graphs basically, but at the far end of it is the outcomes that you want. And you specify the outcome in terms of a goal. If you put a metric on it, then it's measurable. Oops. Right, and then the decision levers are the possible things you could do. And in between them, you've got some external factors that you have no control over. They're red. That's just the way it is, unfortunately. You know, the laws of physics. You know, we can't exceed the speed of light. We can't do things like that. And then the intermediates are the right questions to ask. What are the things, and maybe I can use machine learning to predict the outcome of this, or maybe I actually have to talk to somebody, or I can do a random controlled test to find out. If we don't know and nobody knows, then we got to try, right? And see, and set those things up to come up with the right questions about that. So this is a picture of one of her blog posts. It's pretty busy, but it's a causal diagram, which during she was working with a company that was dealing with COVID. And you know, their outcomes were that they had less people get sick and hopefully nobody dies, and we had to remain profitable, right? We can't just go out of business because of this. There's a bunch of factors that they looked at. The external factors are the red ones, the building design, all these other things that they couldn't change. And then the yellow ones on the left-hand margin there are the decisions they could have made. Which one's going to have the best outcome? They put it through these sets of, and these are the data assets they had. And sometimes, you know, you got to do a flow experiment. You might have to do a random control trial, but this is really focused on trying to figure out which is the best way to do that. And this is the Einstein way of doing it, is take the time to figure out what I need to know so that I can know it. All right, so let's summarize. And then I think I'll have a couple of minutes for questions because I blasted through this pretty quickly. To summarize here, I think semantics matter, right? It's just semantics. Well, unfortunately, it matters. And this is something that's relatively new to me. I've spent a lot of time on the real, I consider real things are, you know, data is real and the rest of the stuff is a little fluffy, but it's actually, it matters. Information alone may not be enough. We can have, there's no end to the amount of information. As long as you can ask another question, and there's always more questions, like what's the next question, right? We'll never get out of that cycle until we start capturing the knowledge of these things. So knowledge is what's required for wisdom, and wisdom is what we're trying to do, is make the right decision, right? Knowledge graphs can leverage your data, making it more useful. That's how we can make our data more useful and increase the utility of our data, so that hopefully you're not sitting in this meeting room. That's my goal, is not to sit there and do all the analysis of this data and find out that nothing is useful. All right, thanks very much for your attention here. I've got a few minutes if there is any questions. Otherwise, you guys can go. I want you to read this. This is more knowledge about bears. This is an actual sign in Fort Steele campground. I'll come back to the bear. Don't poke the bear. And it's important to be able to tell a grizzly bear from a brown bear. The spoiler rate at the No. You got to read the last sentence. If you read nothing else, just read the last sentence. If it's not readable, you know, it basically says they advise outdoor people to carry around pepper spray and wear bells to warn off the bears. And then you should also watch for fresh bear activity, like looking at bear scat, because grizzly bear scat, you know, it has bells and whistles and smells like peppers. That's the difference between a grizzly. That's knowledge that you can use. Anyway, thank you very much. Appreciate the time. Do we have any questions?
Online. Is are you doing this work for a client or in the last year? What happened to you during COVID? You weren't doing this, you were Mr. Data Vault.
Yep.
And then COVID hit, and now you're like, oh.
Well, you know, I'm still doing Data Vault training. I'm still doing Data Vault stuff. What people are, what I've found and frustrated me is people still are making stupid decisions, in my opinion, even in spite of the data. Okay, so Bruce is back. You know, don't be stupid, right? And how can we be smarter? Well, we can use the data better. And I've worked with a couple of companies, Farm Credit Security, and a couple of insurance companies who are building decision engines to help. You know, they need to be able to offer policies through the web and make sure that, you know, they can ask you the right questions to make sure you're worth insuring or loaning money to, or all of these other things. So this is what they're working with and helping them do that. And in order to do that, one of the things that we worked on was and again, it was, we use a tool called Otter. I don't know if Otter is a voice recognition thing that it's an add-on to Teams. Of course, Teams has it now, but they were out a little earlier. And so you can do your interviews. Otter.ai. Yes. Yeah. So you do your interviews with the people who know what they're talking about, and you record that and then transform that into text and then feed that into a knowledge ontology building things, and you get to be able to it quick start you. Right now it doesn't do the whole thing. I think, you know, it's only a matter of time before it does, but right now there's still a fair bit of work in order to do that. But you can take all of your documents, all of the artifacts that you've got, and through natural language processing come up with and plug that into an ontology that gives you that capability. And that's really what they're trying to do, is make some decisions. In some cases, like, you know, there's still a lot of reluctance, and I kind of agree that, you know, I don't know that I want to have the computer make all the decisions, but I'd sure like to be able to. The killer app for me is Google Maps when I'm driving along and it comes up and says, hey, there's a faster route. You know, it knows my goal is I want to go there and I want to get there, and it knows all of the constraints that exist, the externals, but it also dynamically, you know, looks at traffic patterns and speed and how people have gotten through this area, and will make a better recommendation for it. All right, any other questions? Thanks again.
Thank you.
Thank you. Awesome.